Welcome to the All Things Circular podcast, your gateway to the circular economy. Hosted by industry experts Victoria Darcy and Rich Bulger. Every episode is proof that circularity isn't just good for the planet. It's a smart business decision. Our mission is simple: to empower, to inform, and to show you how to make the circular economy work for you.
Hello and welcome to another episode of All Things Circular. I'm your host, Rich Bulger, and I'm here with my good friend,
Peter Evans. Hey, hello, everybody.
And we've got a very special guest, an innovator, up and coming, a new company that's getting just a ton of hype and attention, the Alexander Olesen from Buckstop. Alexander, welcome to All Things Circular.
Rich, Peter, thank you guys for having me. I'm excited to be here.
Yeah.
So, Alexander, what are you building at Buckstop?
So Buckstop is an end-of-life management platform. The kind of core tool that we've just launched is an appraisal engine for the renewable energy space, where we basically help folks proactively value their assets in resale, recycling, while looking at all the regulations that come into it.
Interesting. So tell us a little bit about the size and scale of what you see out there with respect to something like solar.
Solar specifically is a really interesting spaces, and you've got about 50,000 gigawatts of solar deployed last year alone, which is staggering. And then just looking at it another way, we see about 7 gigawatts coming offline in the next few years. So this is really kind of a nascent waste stream. As you think about kind of the waste as a lagging indicator, it's got all this growth, but then following soon behind is that waste curve. And so we're starting to see that really kind of hit in the clean energy space, broadly, both solar, batteries, EV charging infrastructure. And that's a lot of our work is actually just trying to measure this stuff, figure out where it is, what it's worth, and help people kind of proactively think through circularity strategies so they can hopefully recover more value and not get left with a big bill at the end of it.
So this is an interesting problem, and we've been talking about this for a while, but when you introduce something that sounds great, a concept like green energy, which has all kinds of connotations of doing what's right for the environment, you would think that when a solar panel is developed to keep us from mining the earth for oil and gas, that there would be an exit plan for the infrastructure that's needed for green energy. And when you're talking about gigawatts panels that are going on, coming off, you would think that there was a plan to go through and responsibly reuse that material, but it sounds like that's not the case.
Yeah, it's somewhat ironic, right? That you've got the clean energy space that has a waste problem, but I think it's just you're looking at very long duration projects with solar, kind of looking at 25 years plus, and so unfortunately, when the industry was getting going, a lot of people weren't thinking about this, and it's only now 20, 25 years down the line that some of those early projects are coming up for end of life, and people are kind of scrambling to figure out what to do with it. And I will say that it's favorable that both the regulatory landscape and some of these like OEMs and developers, like it's really changed. I think that there are a lot of lessons from oil and gas where there are some serious cleanup jobs that were left to local governments through some somewhat dubious practices. And so, you're seeing decommissioning bonds, landfill bans. There are a bunch of things that are implementing. And, just this year alone, 2 more states added landfill bans. So it's a fast evolving landscape that's kind of forcing these developers and the OEMs in the solar space specifically, but also some others to really think through end of life and start planning for it.
So tell us a little bit about what end of life means. Is this till the end of the assets, like 25 years, or are there solar projects that are getting repowered as well, and so they may actually be deconstructed earlier than that 25-year lifespan that's usually attributed to solar?
Yeah, so we really position the company as a circularity platform. We have this really great advisor who introduced us as the idea called the Circularity Delta, and there's this. And that's really like the core of what we're doing is helping folks figure out you've got these assets, they're in the ground, they're deployed, when are they going to come offline, and what are the scenarios both in resale or recycling that what's the cost associated with that, and how could you recover value? And another way of looking at that is also when to recover value, right? So for some of these projects, solar specifically, the new panels are so much more efficient, they're so much cheaper. that many folks are repowering way sooner than anticipated. Like we've heard stories of, as soon as year 12 in a 25-year project, just because the economics line up. And so when you add that into the equation, you're actually going to see a lot more panels coming offline, but these aren't waste. They're not like end of life in a decommissioning sense. They're working panels that are 12 years old. They've got another, 12 years plus to run. They're just not good in the current climate in the US. It doesn't mean there's not another life for them. But there are some nuances with energy and industrial equipment. It's hard to move. It's hard to find markets. So we're working through all of that. But we hope that one of the outcomes of our tool is we stop hoarding, we stop a lot of the stuff going to landfill, and we help find a second life and then eventually recycling, whether that's domestically or in developing countries.
Yeah, really interesting. And this is the common reverse logistics problem across any industry. And it's just ironic that we're seeing it in green energy, where you build it, you put it out there, and we'll just figure out what to do with it later on. So interesting that quandary still exists within green energy, but you are attacking it in not just a way to go through and foster recycling. You're actually looking at it from a value proposition. And one of the things that Buckstop has done is invested in tools and technology. Just read a recent article likening the residual value of solar panels to Kelley Blue Book, which is used in automotive to help people understand what the residual value is. So can you help us understand, how are you applying a Kelley Blue Book approach to solar?
So I think it's just to look at Kelley Blue Book. It was one of the kind of key information layers that formalized the aftermarket for automobiles, right? So in decades ago, people just left their cars rusting on the side of the street, and it was actually the Cold War geopolitical tensions that drove the need for recycling and recovery of that material. Kelley Blue Book emerged as a tool to help kind of set pricing for reuse and eventually recycling. And now, as you guys know, 97% of vehicles are recycled. It's the most circular industry on the planet, and people don't really talk about that. And so, we think that can and should happen in every other industry. And so the methodology we developed is what we call an algorithmic assay. So it is a tool to basically deconstruct finished goods into their raw material parts. And therefore you can assign value to them. And so we think it gives a kind of a much more granular look at the true residual value in terms of material composition in a way that scales. And so our goal is really to cover everything with the plug eventually, but you got to start somewhere, and solar is where we're starting. So that's really come a long way. There's a lot of kind of data engineering behind that. And then we also look at kind of, as I mentioned, resale and regulations. And so between those kind of three pillars of kind of material, resale, and recycling, you get a very holistic view of what's this asset worth at any moment in time. And once you measure it, you can start to improve it. And so we think it's a really useful tool. Certainly in solar, it saves a lot of time, and it provides information where there really isn't a standard today. But in the long run, we think this is kind of one of the ways that we can move the kind of resale and recycling rate across the nation. The US sits at below 20% of electronics being recycled. That is very low by international standards. It's actually like an environmental and an economic waste and a value destruction event that's happening at a national level. And it's like, well, what if we build the framework to measure that? And once you have that measurement, does that unlock a lot of feedstock, both in solar, but all these other industries that should be really beneficial for your downstream recyclers, resellers, et cetera?
Interesting. So 2 questions. What are solar panels made of, or the solar industry? What do they typically deploy? So what are you analyzing when you look at your appraisal tool? And then what is the scope? Is it just the panels, or are there other peripheral kind of components that go into creating a solar project?
Yeah, so we try and take a holistic view of the electronics installation. So we look at both the panels, obviously that's the kind of lion's share of it, but also the racks, the inverters, the wiring, any battery storage, kind of the full landscape. We're not getting into the foundations and the fence posts, but just anything that's associated with the electrical hardware. We try and take a whole view on that. And from a material point of view, solar panels are tricky to recycle. There's a lot of investment going into that area, but the economics are not positive yet. You're looking at a lot of silicon rates, mostly glass, some trace rare earths like silver and other things, but it's aluminium racking. but then you do have kind of steel or aluminum frames and copper in the wiring. So from a material like mass point of view, there's a lot of it, but from a kind of weight to value ratio, it's still a challenging segment to recycle when compared to like batteries or consumer electronics.
Great. Alexander, you've done a lot of research. You and your team are some of the brightest minds that I've come across. And I know that you have been tackling this question, how do you keep green energy green? Can you walk us through your exploration process of how did you get to Buckstop and how did you come to the idea of building a platform that specifically addresses green energy? I love the concept of starting with solar. I think a lot of people see solar farms, they see solar panels on people's houses, and there's a natural question of what happens when those come off. But walk us through, how did you zoom in on this particular problem?
Yeah, so I think it starts my previous career. We played a leading role in kind of building out an OEM in the vertical farming space, and it was a small scale OEM, but we were developing basically in like IoT devices, electrical equipment, shipping it across the world. So it was a steep learning curve. But one of the things that became very apparent over kind of a 10-year period is this stuff all goes obsolete, and even before it goes obsolete, there are all these other reasons from free weather to churn that just stuff comes offline, and it just is it's a kind of a consistent part of business, whether you're in solar, micro farming as we were. And what I knew, our bill of materials, we had 1,200 components in each device, and yet when things came offline, we couldn't find anyone to recycle them, we couldn't find anyone to use components, and it just kind of struck me that like was insane. Like I knew that we had thousands of dollars of metal in this machine, and yet we were putting it in the landfill, and that like still pains me that happened, but it was honestly the only option. And so it's something I've been thinking about, like as all of these distributed hardware systems come online, like isn't just think the exponential growth in renewables, robotics, there are a lot of different systems, and micro farms is a super niche version of that, but it's a problem that everyone faces. And so I got to know folks in those segments, and they were all like, yeah, like we don't know how to deal with it. Like our operations teams do not want to deal with this. They don't really care. They want to install the new thing, not worry about the old thing. So I was like, well, like, why isn't there a comprehensive end of life platform? Like that was kind of my lens. And so we really try and design these tools for the folks who own and operate these assets. So that's kind of where we come from. And as we kind of went through this research process, we were looking at, just where are the biggest, waste streams coming offline. And that's really where we landed on kind of solar and some of the peripheral kind of clean energy segments where there's a lot of this stuff out there. It's growing exponentially, and that kind of waste rate is following fast behind. So I think we've got a really interesting tool, and it's kind of meeting the moment in a way that's actually going to help the folks who are deploying these assets, save them a bunch of time, and hopefully help them recover more value in the process.
Great. So where are you in the process of rolling this out and go to market? Or do you have a beta or something that people can come and check it out and see what it's capable of doing? And then who are you sort of targeting? What is the users that you think would benefit most from this kind of appraisal tool?
Yeah, so as far as kind of our development cycle, we've been kind of building out the frameworks for this for over a year, but we literally just launched the beta at the end of September. So that's in kind of a private beta right now. We're closing in on 1 gigawatt of solar on our wait list, which is super exciting. We're taking on clients and kind of just running these appraisals, learning. So the plumbing works, the data, is there, and we're super excited about the level of interest. And yeah, we're taking waitlists as well for kind of adjacent segments. So we've had a lot of interest from EV charging, battery storage, things like that. So anyone in renewables can sign up today, and we're kind of racing behind the scenes to kind of layer on the functionality to support them.
Help people understand how big a gigawatt of power is.
For the Army truck drivers out there, like me, that are having a hard time framing
like, what's a gigawatt of solar?
What I see on people's roofs.
It's fine. I need to ask ChatGPT. I'm trying to get my head around it myself, but it is
no, it's a lot of power. That's why I flag it.
Yeah. So like I think one way, I think a megawatt, so there are 1 million megawatts in a gigawatt, is like an acre. I think it's something like that. So there's a lot of this stuff going out there, and when you drive down the highway and you see a field full of solar, that's probably a couple of megawatts, which is
well, I think of it in terms of like a combined cycle gas-fired power plant. They're typically 250 megawatts,
Am I the only
So
one that thinks about how many DeLoreans can you send back to the future?
so anyway, it's quite a few. I mean, nuclear power plants get up to a gig. So it's amazing that you've been able to sign up that many or that volume of solar.
Yeah, so it's funny. Just so it's sorry, it's 1,000 megawatts in a gigawatt, and it is
Yep.
about the same size as a nuclear power plant. So
Yep.
as a reference point.
There you go. Just
So,
grounding
Alexander,
people in,
Yeah.
in the scale.
So,
Alexander, one of the things that we commonly talk about is end of life, but a Kelley Blue Book type of product. And one of the things that really helped the Blue Book go to market and just accelerate, because the Kelley Blue Book came out in 1917 when a used car dealer started recording what he was able to buy and sell used cars for. So he'd buy low, fix them up, sell them high. And he used that to go through and make money to open up his first dealership in California. Then by, I think it was 1926, the government got wind of the work that he was doing. He was selling his Blue Book to other dealers to help them go through, buy low and sell high. And then when the government started using that Blue Book as a vehicle, no pun intended, to assess property tax, then the Kelley Blue Book became the standard. There's all kinds of things going on in relation to government and funding. We'll get to that in a second. But can you help us understand how a residual value tool like a Blue Book is used in solar at the point of installation during the permit process, used as a trigger, as Peter was talking about, while a thing is in production to make a decision, do I keep or do I upgrade? And then addressing the end of life problem of, well, what do I do with it when I no longer need it? But it's not just that. There's various aspects along the way where understanding residual value can help decision making.
yeah, it's a really good question. I think the way we think about it is that, like, who are the stakeholders involved in the life cycle of an asset? And for solar, these are pretty big capex intensive projects. So even to
Mhm.
build one, you've got permitting. You've sometimes got decommissioning bonds. They make you put money down to like prepare for end of life. So that's a growing trend. You've got lenders and like banks who are financing the project. So what are they financing? How do they know what it's worth in a downside scenario? Same for insurance. So these are all kind of key stakeholders for all of these projects that actually need salvage values at the like almost before the thing's even built. It's one of the key kind of risk variables that they're underwriting against. It's like sort of what happens if the company's not around? Can I use this thing? Can I salvage it? Right. And so that's really where we found that actually we're adding a ton of value because there's no kind of routine methodology around that. It's very kind of opaque data sources. It's a lot of kind of independent consulting projects that are essentially repeating the same calculations for every project. And so it's time consuming, it's expensive. And I think we're bringing a tool that kind of just helps streamline that. And we're like, look, here is, we're sourcing this from hundreds of like different places. We've got the, you can see the sources and the calculations. We're kind of making it very easy for folks to calculate that and hopefully bringing some standardization that will benefit not just those asset owners, but all of those other stakeholders. And then of course that comes into its own again at the end of life because the recyclers and liquidators also are like, well, like what am I dealing with here? Someone calls you up and says, I got a gigawatt of solar. What does that actually mean? Like who made the panels? How old are they? Like what kind of racks? These are all like what's under the hood kind of questions. And I think that's
Mhm.
where providing some standardization and can really help these folks make, just make their life a little easier quoting things and again, figuring out how to recover value at the end of life as well as at the beginning.
So how does the AI work? You've talked a little bit or told us in the past that you're deploying AI tools. So are you building like a library of existing material and then also understanding commodity markets and then stitching this information together to come up with the appraisal assessments? Curious how the stuff happens behind the scenes.
It's just we just call it magic. No, they there's a lot of things going to. I think that the challenge is um, pooling all of the data sources and yeah, so a library is kind of a good way of kind of conceptualizing of like what's out there, what's it made of, where are the
Hmm.
resale channels. These are all kind of big exercises that we're doing, and yeah, we go all the way through to the kind of COMEX and the LME. So these traded commodity prices, like that's kind of getting close to what people are paying for those raw materials at the kind of smelter. And one of the other challenges that I think exists across the kind of scrap and liquidation markets is super fragmented. There really isn't much information, and we've heard that a lot of this stuff goes between a lot of middlemen, but there are smelters and things who are buying in bulk, and it's like, how do you help sort of standardize the market, which again will hopefully unlock a lot more feedstock? Because today it's like, well, if you're the asset owner, you don't know what your stuff's worth, so you pay someone to take it away and then they go make money off it, and that's fine for now, but it's actually probably not the right way to really unlock a lot of this value. And it's one of the reasons that consumers and businesses hoard so much stuff, is because they're like, well, we know it's worth something, we don't want to sell it, so we'll just sit on it, and you're destroying value by sitting on it, and there's obviously costs associated with that. So we're just trying to kind of bring some rigor to how you'd actually catalog those assets and value them.
So as you're talking, I'm thinking really what you're building is a decisioning tool, right? To make better decisions about how to handle these assets.
That's exactly right. And I think it's really both the data sort of crunching behind the scenes that we're having a lot of fun doing, but there's a lot going into it, and then really building like a great user experience. I think that's also part of this. It's like data for data's sake is not that useful. Actually, it's trying to build a nice UI so that any operator on the ground who's dealing with a decommissioning project or they're clearing out a warehouse can actually just really quickly value kind of a wide range of assets. I think that's actually one of the things we're most excited about, is just bringing a nice kind of product to market that people can use and very quickly get the information they need to make better decisions.
Earlier this week, I was in Austin at DHL's annual event. This year, it was called Now and Next, where DHL CEOs and senior executives bring in key clients of CEOs and senior executives, government officials tackling world problems and trying to figure out how to go through and address them, or present solutions that go through and address them. And one of the key things that kept on coming up was the reliance on China and the recent news around restrictions of critical or rare earth materials. So I guess my question is twofold for you. Leveraging the technology that you have and the solutions that you're trying to build, what are you seeing the government's response to trying to find alternative solutions? And how is your technology addressing green energy, helping us urban mine or get access to rare earth materials that we've typically been relying on foreign countries for?
Yeah, it's the question at the moment, and really it's been kind of fascinating to watch this year, since we've really been kind of diving and building in the background to just see the kind of geopolitical landscape shifting. And then obviously even last week, I think they're now implementing price floors for certain critical minerals, which it's been pretty unprecedented for the US to even consider.
And interesting. That kills the advantage.
Yeah, well, it's interesting. Yeah, from a geopolitical point of view, it does, but it's like, okay, and then what? We actually don't have any domestic refining capabilities.
That's the question.
I think one of the things we talk about a lot, and there's so much innovation going into downstream processing. So new mines, new processing. On the recycling side, you've got kind of biogenetic facilities that are leaching out rare earth elements. Is super exciting. You've got robotic processing facilities. These are amazing things. They're going to take a few years to get online. In the case of new mines, you're looking at decades, even with the change in kind of administration trying to push things through. So what does that actually mean in the short term? It means recycling is like the only option. And so while all of these innovations on the kind of processing side can change the unit economics of recycling and help us recover more, none of them can be successful without feedstock. And that's really where we come in. So we're building out the tools to help measure deployed feedstock, both in resale and also the raw materials and critical minerals being a subset of that at scale. And one of the kind of conversations we're having with DOE folks and others is like, we want to essentially take inventory of the deployed feedstock within the grid, within these solar facilities. And you look at some of these large, energy and utility companies, they can have like millions of assets across multiple states. Like it's staggering the scale, but they don't know what they have in terms of deployed metals and what to do with them. And so again, that's really where we come in. And I think in the current climate, we're seeing so many tailwinds for this sector. And it's like, okay, it's really just a question of how quickly can we get out there and help folks realize what they're sitting on.
That's exciting. So We talked a lot about solar. Are there other sectors or products or materials out there that you're looking at besides? And just curious kind of what the longer term vision is for Buckstop.
Yeah, so our goal is everything with a plug. That's the
Everything with a
goal. Is
plug.
Yeah.
Okay.
So as in it's a lot to get there, but we think we can do that in the next couple of years, at least on the ability to analyze it. I think there's a separate conversation about how you actually kind of get out there into those markets successfully. But for us in the near term, like renewable energy is kind of our sole focus. Solar, batteries, wind, and kind of EV infrastructure is
Hmm.
there's a lot of that out there. We're gonna have our hands full. And we're really excited about the adoption so far, even in this kind of beta phase.
So you'll build a appraisal tool for each one of these sectors. Is that sort of how it'll work? What's the entry point that a user would kind of enter and think of, access your tools?
I think a way to think about like Kelley Blue Book, right? It's a pretty simple UI, right? It's like I think it's your make a year and maybe the VIN number, and you get the
Hmm.
results. Like we're aiming for that level of simplicity, but the coverage of products behind the scenes is much broader. I think that's one of the main technical challenges here is like how do you create a common
Right,
language to appraise these assets that are very non-uniform and varying,
right.
in different, geographies, different regulations. And so that's really kind of what we're specializing in is how to create that common language and value these things.
Yeah, I mean, a car is a discrete item, right? It's got similar attributes. It's got tires, it's got a hood, it's got an engine, it's whatnot. But these clean energy assets are quite varied in how they're constructed and what they do. So I could see the complexity. But I would imagine these days with machine learning and other techniques, some of these challenges can be overcome.
Yes, and that's a big part of what we've developed. We call it an algorithmic assay, but really the ability to understand these assets. And I think that we're starting to see that compound now, and we can kind of take that across different sectors. So we're excited about it. But to your point, like these are tricky assets, and we're really if we get it right, you're kind of redefining how the asset class is valued. Like it's no longer waste, and it gives you a way to view these kind of objects in their raw material terms, which is great for kind of the recyclers who want to recover that material. And then if there is a resale channel, that's great for folks to kind of have another life cycle and use the asset, whether that's domestic or internationally. So we see
Right.
that as like we call it the data layer for the circular economy.
Yeah.
That's really what we're trying to build out here.
Well, also hard can be good because it creates a moat. If you can crack the nut, then it's hard for others, then you have a competitive advantage in the market. And starting early, right, that first mover advantage. I don't know of any other company that's doing something similar to you. So that's an advantage, obviously.
Yeah,
Well,
and going back
hope
to the analogy of the car that Peter was using, I'll use his car. The hood, the tires, the engine. His would probably have some DJ equipment that's scattered around in there somewhere, and you can figure out what the raw components are. You know, the rubber, steel, plastic, whatever it is, and there's readily accessible information into what is the current market rate. And matching that to an appropriate downstream recycler that's a challenge, but you can conceptualize that. And that's what a lot of people think of when it comes to recycling. But you're not just doing that. You mentioned resale as well, which means you're understanding who the second, third, and fourth customer is, perhaps, of this equipment that has a higher residual value that you can get. You'll get more if you sell your car in most cases than you will by throwing it in the chipper,
Scrapping it,
grounding it
right?
up, and recycling it. So, Alex, let's understand, how are you getting information on who customer two is for anything with a plug? But we'll start with solar.
Yeah, so I think the way to look at it is in a commodities context, right? You run netback models, which basically take a uniform good and look at the kind of ports of entry and the shipping costs to really figure out where's the most efficient place to sell it. And that's in a liquid market, and that's, those are pretty well-trodden paths. But for some of these assets, it's like, well, there is a buyer, and there are a lot of places around the world who are desperately in need of new energy sources and new sources of power. So one of the things we see, is prolific in the U.S. They call the U.S. the Saudi Arabia of scrap, right? People come here,
Really?
aggregate.
That's a new one. I like
Oh
that. The
yeah,
Saudi
that's in
Arabia of scrap. Okay.
Junk Your Planet by Adam Minter is a great book, and he calls it that, and that's apparently a saying. But the same goes for resale, right? So a lot of these wholesale marketplaces, people come, aggregate stuff, and then ship it to another country where there's high demand and make more profit. And I think as you look at energy assets and some of the other things we're doing, it's like you're factoring in logistics, and then you're looking at kind of where are the vibrant kind of resale markets and end points in the supply chain. And I think that, again, a lot of data crunching, a lot of work to figure that out. But once you have that, you actually have a much more efficient way to kind of route these assets to places that really need them. And you're removing steps in the supply chain, which I think is better for the asset owner, and it's better for those kind of endpoints in the market. So that those are the things we're trying to figure out. And today, a lot of this stuff just gets passed around until it's aggregated and then shipped to one of these places for resale, that is. So we're trying to kind of help measure where these things can go and where's economically viable for them to go.
Yeah, I've also been looking at some of the parts or spare parts markets in the oil and gas industry, and they're paying pretty high carrying costs just to keep these things in warehouses. I don't know if you've looked at that at all, but I would imagine if you looked at the US utility industry, they're sitting on huge amounts of assets. They're actually not in use. They're just sitting there as spares or waiting for a project, or a project got canceled and they're sitting there. So this appraisal tool, I could be used in those context as well, I would imagine.
Yeah, it's really interesting. We like to talk to our clients about like the residual value is never zero. There's always something that from a material point of view, but in the same breath, the cost of doing nothing is never zero. And I think that carrying cost is something
that's really important.
they
Yeah.
often overlook. So they might be, we've spoken to companies with hundreds of thousands of square feet of warehouse space dedicated to storing old assets. And it's like there is a cost to that, and they kind of set it and forget it. And we like to kind of bring visibility. And I think one thing that's interesting though, as you look at kind of circularity space, I think there's a lot more need for reverse logistics, warehousing, repair, refurb shops. And I think that potentially developing countries are going to fill that void. We're not going to get into that space, and neither are we going to get into processing. We're trying to be the kind of enabler and the valuation tool that helps all of those people kind of make better decisions.
Well, again, make better decisions about, hey, should I just leave that in a warehouse? And like you said, it accumulates and they have to pay out every month, usually, right? Holding fees for these things.
There's a old radio announcer I used to listen to when I was younger, Paul Harvey, and he had a phrase, "There's no such thing as a free puppy." I turn that into there's no such thing as free inventory. And a lot of that is just an accounting concept. Well, hey, listen, I paid for it. It's depreciated. Therefore, it's free. It's not on the books anymore. But when you add in understanding residual value with the circularity delta, what did you pay for it? What is it actually worth? Which oftentimes has a lifespan past a 1 to 2 year depreciation cycle. Now you've got decisions that need to be made in addition to what you and Peter have been talking about with, well, how much does it cost to store something on a shelf? Audit it. Move things around when you need to go through and find more space. Those things get caught up in not just the ownership, the payment for the first asset, but it's colored on the books underneath operational costs, which is typically a different line item. And it's been very hard, in my opinion, for companies to understand the true total costs of ownership. Therefore, when it's depreciated down to zero, it's a free puppy. We just don't need to worry about it. We'll leave it on the shelf.
Yeah, totally. So, Alexander, we like to ask about myths. Do you have any myths that you've come across in this industry? And what do you think would be good ways to rethink those myths?
So I do. I have a favorite myth at the moment, which was startling to us, but something we're kind of helping to calculate a new way. But there is a notion in the solar industry that your decommissioning costs will net out against your residual value. And that was the base case for all of the early solar plants. So if you own and operate solar today and you're coming up for repowering or end of life, they're getting quotes for decommissioning, which is a big bill. And it is definitely not going to net out against your salvage values. And so I think it is something that is a myth that is being busted at a lot of cost for some folks out there. And I was just at a solar energy conference where it was kind of the main topic of like, we need to employ one of many like key topics around circularity of like, this is someone's left holding the bag. And if you're a solar operator and you want to sell your company, the companies who are buying now know like your decommissioning costs are a huge risk to this business. And historically, no one's been calculating them. So that's my fun myth that we are helping hopefully to kind of mitigate.
That's really insightful. And worth an article on that one, I think. Yeah.
And very common, just like we talked about at the beginning of the podcast. When everything is great and you're selling and revenue's coming in, we'll just figure it out later on. And the can gets kicked down the end of the road. And what I found being a reverse logistician is logistics is a game of hot potato. And the person at the end is always reverse logistics. So if anything breaks along the way, they're the ones that have the bad news at the end at every step, which is really important to go through and make sure you have an integrated circular logistics program where you can get ahead of what's going to happen when things come off. But not surprising in solar, now that things have lived on homes now for 15, 20 years and are coming to upgrade cycles or end of life cycles, that these challenges that weren't even thought about at the beginning are now coming to a head. So it's really great that there's action-oriented, creative, AI-powered, caffeine-fueled sustainability superstars like Buckstop trying to go out and tackle these problems. Alexander, final thing, I know you just launched your company. How do people find you?
Well, again, thank you guys for having me on here. So the best way to reach me is Olesen Buckstop on X or on LinkedIn. Or of course, our website, www.buckstop.com.
Yeah, well, thank you so much for coming on. Super interesting conversation. I think very insightful and not a topic that a lot of people have deep expertise on. So we feel really fortunate that you've been able to share these insights with us. Thank you.
Green energy is not green unless you use Buckstop. Really cool thought. All right, Alexander, thanks for joining us today.
Yeah, thank you so much.
Thanks for tuning in. Please head over to allthingscircular.com to learn more.